Hello everyone, I'm Venkatesh. I'm here to discuss about ZigBee technology. So let's quickly get to the content of this video. First we'll discuss about introduction, like how ZigBee has evolved, and then we'll see what is ZigBee, and then what is ZigBee and this IEEE protocol and the connection between both of them, and then different type of ZigBee devices like physical type device, logical type device, and then different ways of accessing this ZigBee device, and then ZigBee protocol stack, which means the different levels in ZigBee device, and then topologies which ZigBee device are compatible with, and then finally applications of ZigBee. As we all know, wireless technology is being developed rapidly nowadays, and the main motive of this wireless technology is like all kind of portable applications should be able to communicate without the use of any wires. And then we'll see what made scientists develop this. Actually, ZigBee style networks were planned around 1998 when many engineers realized that both Wi-Fi and Bluetooth were going to be unsuitable for many applications. In particular, many engineers saw a need for self-organizing ad hoc digital radio networks. Now we'll see what is ZigBee. The name of the ZigBee came from zigzagging patterns of honeybees between the flowers, which represent the communication between nodes in a mesh network. And it is a wireless networking protocol based on IEEE 802.15.4 standard, and it is the main technological standard created for controlling sensor networks, and it is mainly created by ZigBee Alliance. There are many companies in the ZigBee Alliance like Ember, Freescale, Chipcon, AMI Semiconductors, and there are many more. Now we'll discuss about ZigBee and IEEE protocol. First of all, these two are not the same. ZigBee is a standard based network protocol supported solely by ZigBee Alliance that uses the transport services of IEEE 802.15.4 network specifications. ZigBee Alliance defines the network security application layer, whereas IEEE protocol defines the physical and media access control layers for LRWPAN, which means low rate wireless personal area network. ZigBee Alliance is responsible for ZigBee and IEEE is responsible for IEEE 802.15.4. Power needed for ZigBee is very small. In most cases, it uses 1 milliwatt or even lesser power than that. But still, it provides range up to 150 meters in outdoor, which is achieved by the technique called direct sequence spread spectrum. Also, this technique consumes lesser power compared to frequency hopping spread spectrum. The IEEE 802.15.4 standard employs 64-bit and 16-bit short address to support theoretically more than 65,000 nodes per network. That means you can imagine how big it is. ZigBee network can have up to 6,53,356 devices, and the distance between them can be up to 50 meters, and each node can relay data to another node. This leads to the capability of making very big networks which cover significant distance. ZigBee devices are the combination of three things. The first one is applications such as light sensors, lightning control, etc. And the second one is ZigBee logical type device. They are coordinator, router and end devices. And the third one is ZigBee physical device types, and they are full function device and reduced function device. Now we'll discuss about them individually. Now we'll discuss ZigBee physical type device. Based on data processing capabilities, they are divided into two things. One is full function device and the other one is reduced function device. The full function device can perform all the available operations within the standard, including routing mechanism, coordination task and sensing task. It even plays the role of coordinator or router or end devices, which means it can act as either FFD or RFD. Whereas RFDs on the other hand implements a limited version of IEEE protocol. The RFDs do not route packets and must be associated with an FFD. These are like the end device such as sensor actuators, which only doing limited tasks like recording temperature data, monitoring lighting condition or controlling external devices. The current ZigBee standard requires FFDs to be always on, which in practice means that FFDs must be constantly powered. Now we'll discuss about ZigBee logical type device. There are three categories in this. They are coordinator, router and end device. Coordinator forms the root of the network tree and might bridge to the other networks. In every network there will be only exactly one coordinator, and it is responsible for initiating network and selecting network parameters like radio frequency channel and unique network identifier. Whereas router acts as intermediate nodes relaying data from other device. Router can connect to an already existing network, also able to accept connections from other device and be some kind of retransmitters to the network. Network may be extended using ZigBee routers. And then end device. They can be low power or battery powered device. They can collect various information from sensors and switches. These end devices will be having sufficient functionality to talk to their parents, either coordinator or router. These devices do not have to stay awake the whole time, while the other devices like coordinator router have to. As we can see in the diagram, there is only one coordinator to the network, which is used for selecting the network parameters, and these are routers, and they can be used to expand the network, and these are like end devices. Now we'll see different access modes. There are two ways of multi-access in ZigBee protocol. They are beacon and non-beacon. In non-beacon enabled network, every node in the network can send the data whenever the channel is free. Whereas in beacon enabled network, nodes can only transmit in predetermined time slot. To transmit in predetermined time, there should be some mechanism which is taken care by the PAN coordinator, which allocates guaranteed time slots for each device. Therefore, devices will transmit their data during their own slots. Now let's talk about ZigBee protocol stack. This protocol architecture is based on OSI model. ZigBee builds on IEEE standard 802.15.4, which defines the physical and medium access control layers, whereas ZigBee Alliance defines the network layer and application layer. Now we will discuss about individual layers. The physical layer of the IEEE standard is the closest layer to the hardware and which controls and communicates with the radio transceiver directly. It handles all the tasks involving the access to ZigBee hardware, including initialization of hardware, channel selection, and link quality estimation. Whereas the MAC layer provides the interface between the physical layer and network layer. This provides two services. One is MAC data service and another one is MAC management service. MAC layer is responsible for generating beacons. We have already discussed beacons in the last slide, and synchronizing devices to the beacon signal in a beacon enabled services. Whereas network layer provides interface between application layer and MAC layer. This layer is responsible for entire network formation and routing. Routing is the process of selection of path to relay the message to the destination node. This forms the network involving joining and leaving of nodes, maintaining routing tables, actual routing, and address allocation. And now we'll discuss about application layer. It is the highest protocol layer and it hosts the application objects. ZigBee specification separates the API layer into three different sublayers, and they are application support sublayer, ZigBee device objects, and application framework having manufacturer defined application objects. Here we can see the figure 1 ZigBee protocol stack. These down two layers, MAC layer and physical layer, are defined by IEEE, and the network layer and application layer are defined by ZigBee Alliance. And now we'll discuss the classification of application layer. The first one is application objects. It controls and manages the protocol layers in ZigBee device. It is a piece of software that controls hardware. And the next one is ZigBee device object. The key definition of ZigBee is ZigBee device object, which address three main operations such as service discovery, security, and binding. And the next one is application support sublayer. The application support sublayer provides an interface between network and application layer through a general set of services provided by application support data and management entities. Now we'll discuss about security service provider. ZigBee provides security mechanism for network layer and application support layers, each of which is responsible for securing their frames. Security service include methods for key establishment, key transport, frame protection, and device management. Now we will see different type of topologies ZigBee devices are compatible with. The first one is star topology. Star topology consists of only one coordinator and any number of end devices. In star topology, a master-slave network model is adopted, whereas master is the coordinator and which is FFD, and the slave will be either FFT or RFT. ZigBee end devices are physically and electrically separated from each other end devices and pass information only through coordinator, which means devices can only communicate with coordinator. Now let's come to cluster tree topology. It's actually similar to star topology. The difference is that other nodes can communicate with each other so that more RFTs and FFTs can be connected to non-coordinator FFTs. Now let's discuss about mesh topology. In mesh topology, each node can communicate with any another node within its range. It's complex to maintain and beaconing is not allowed, but it is more robust and tolerant to fault. Now you can see in this figure 2 the three different topologies. The first one is star. All the nodes have to be communicated only through coordinator, which becomes a difficult task. Whereas in cluster tree, any node can communicate with any other node, which becomes easy for them, and more FFTs and RFTs can be activated. Whereas in mesh, any node can communicate with any other node within its limited range, so it becomes complex to maintain. Now we'll talk about ZigBee applications. The throughput of ZigBee is low. Rate of data transfer is about 250 kbps. So this ZigBee system is useful for applications which needs low data rate, such as home automation and control, automatic meter reading, residential and commercial utility systems, building automation, personal healthcare, and many more like fitness monitoring, ZigBee Smart Energy. So let's conclude this topic. Since there are no global standards so far in wireless sensor networks, ZigBee plays a vital role in most of the wireless application. In most industries, it is observed and there is an increasing demand of ZigBee based wireless applications.